Good afternoon, students. I, Professor Arvind Muddebiha, welcome you to the subject Dynamics of Machines. Here, the course code given for this subject is 18ME44, and today we'll have introduction to this subject. So, why students has to study this subject, or what will be the outcome of the subject, or what are the objectives of the subject? If you look into this, here the purpose of studying this subject is that students will be able to understand the concepts of machines. So, and that is nothing but what is machines, how it is defined, why machines are used, and what are the mechanisms involved in the machines. So how the machine is constructed, how the mechanisms are done, and relative terminologies which are used in these machines and mechanisms. So students will be able to understand all these machines, mechanisms, and related terminologies. And students will also be able to understand the various mechanisms, motion transmission elements used in mechanical engineering. So once student is exposed to these, he will be able to apply his knowledge, ideas in developing new innovative machines and mechanisms. And students will also be able to analyze the mechanism displacement, velocity, and acceleration at any point in the moving link. So that is nothing but you'll be able to analyze what would be the velocity, what would be the acceleration, what would be the displacement of the links which are used in the mechanisms or the machines at any point of working of the machines. And here we are going to have basic knowledge about cams, gears, and gear trains. So this subject is consisting of these all these contents like machines, mechanisms, and its velocity and accelerations, and different theories like cams, gears, and gear trains. If you look into the first module, the topic, the title for the first module is mechanisms. Here we are going to study the basic definitions of the mechanisms, and later on we are going to have different mechanisms and its inversions we are going to study. Before we move to the mechanisms, so I would like to give more information about this kinematics of machines. What is this title, kinematics of machines? Here the we have a theory of machines. Actually, the theory of machine, which is the one which deals with the study of relative motion between the parts of a machine and the forces which act on those parts. This theory of machines is classified into two types, or it is divided into two, that is, one is kinematics and one is dynamics. The study of the relative motion between the parts is known as kinematics, whereas the study of forces which act on the parts is known as dynamics. So basically here we are going to study the relative motion between the parts, which comes under this kinematics of machines. So in this module mechanisms, we are going to learn about basic definitions about different parts of mechanisms like links, types of links, joints, okay, and kinematic pairs, and what are the constants of the motions, and you are going to study about different mechanisms, how the mechanisms are evolved, and what are the different inversions of mechanisms we are going to study. This module 1 consists of we can say 80% of theory, and 20% will be numericals, and very quite important module which will give you the basic information about mechanisms and machines, how the machines are constructed with the help of mechanisms. You can understand that. The next module we have velocity and acceleration analysis of mechanisms using graphical method. As in the objective of the course, we studied that means it is given that student will be able to understand the displacement, velocity and acceleration of the motion. So here in this particular model, we will be analyzing the velocity and the acceleration of the 4-bar mechanisms, slider crank mechanisms using graphical method. And we have, that is, one more graphical method is instantaneous center method. Okay, in this instantaneous center method, we have Kennedy's theorem and determination of linear and angular velocity using instantaneous center method. So here this velocity analysis of instantaneous center method is a one topic or one chapter, you can say, and velocity and acceleration analysis of mechanism using this graphical method is a one more topic what we have in the module 2. And when we come to the module 3, again here you can see the title is velocity and acceleration analysis of mechanisms. Here it is given as analytical method. So in the module 2 we will be studying using graphical method, whereas in the module 3 it is using analytical method. This analytical method of finding velocity and acceleration analysis of, again it is 4-bar mechanism and slider crank mechanism using complex algebra method. Okay, so this will be one topic, and the one more topic will be this Freudenstein's equation for 4-bar mechanism and slider crank mechanism, and function generation for 4-bar mechanisms. So these all comes under the analytical method of finding velocity and acceleration analysis of mechanisms. Next we have module number 4, CAMs. So CAM is a mechanical member, you can say, or a machine element which is used for transmitting a desired motion, that is it can be a reciprocating or oscillating, to a follower by means of a direct contact. The cam and the follower have a linear contact and constitute a higher pair. In other words, or in simple words, cam mechanism consists of we can say cam mechanism consists of a cam, follower and a frame, where cam is a driver and follower is the driven member. And the cams are widely used for operating inlet and exhaust valves of IC engines. These cams can also be seen in the paper cutting machines, in the spinning machines, feed mechanism of automatic lathe, textile machineries, and many other punching and pressing machines. We can see these cams in many other applications. In this module number 4, the cams, we are going to study about classification of cams and the different types of followers. Later on, we'll be studying about the nomenclature of the cam based on the follower motions and motion analysis. We are going to have the cam profile with the different with the offset knife edge follower, roller follower, flat faced follower. We are going to draw the cam profiles. So in this module cam profile, in this module cams, first we are going to study about the theory of the cams. Later on, with the knowledge of that, we'll be able to draw the profile of the cams using this simple harmonic motion, motion with uniform acceleration, deceleration, uniform velocity, and cycloidal motion. With these motion analysis, we are going to have a cam profile. The next module we have spur gears and gear trains. Here, student will be studying about what is gear, and you might be knowing the gear has many applications in many machines like lathe machines. You can see in automobiles the gears are used. The gears are basically used for transmitting motion from one shaft to another shaft. And in this topic, you are going to study about only the spur gears and what are the gear terminologies and other concepts like law of gearing, path of contact, arc of contact. So all these concepts will give you about the gear profiles, how the gear profile is considered, what would be the number of teeth on the gears, what should be the minimum number of teeth on the gears to have a smooth gear motion between the two gears, what should be the diameter of the gear, what should be the gear tooth thickness, what should be the um, the distance between the two teeth. All these you are going to study in this spur gears, and it involves few derivations and numericals. Later on, the second topic in this module is gear trains. The gear trains are nothing but when more than two gears are used in the mechanical system, we call it as a gear trains, where it involves more than two gears. So in this gear trains, we are going to study about simple gear trains, compound gear trains, and epicyclic gear trains, where we'll be finding the algebraic and tabular methods of finding velocity ratio of epicyclic gear trains, torque calculation in epicyclic gear trains. So this is how the syllabus is given with 5 models with the different contents. After studying this subject, the student will be having the knowledge of mechanisms and their motions. He will be having the knowledge of inversions of 4-bar mechanisms. Student can analyze the velocity, acceleration of links, joints of mechanisms, and you will be able to analyze cam follower motion for the motion specifications. So this is a very important and basic subject for mechanical engineers. With the help of this subject, students will also be able to understand the working of the spur gears and analyze the gear trains, speed ratio and torque. Okay, later on in the syllabus, the question paper pattern is given. Okay, here you can see the question paper will have 10 full questions carrying equal marks. Each full question will be for 20 marks. There will be 2 full questions with a maximum of 4 sub-questions from each module. And each full question will have sub-question covering all the topics under a module. The students will have to answer 5 full questions, selecting 1 full question from each module. So this is the question paper pattern for the subject. And next, here we have textbooks and reference books which we can refer. Under the textbooks, we have a Theory of Machines, Kinematics and Dynamics by Sadhu Singh. And we have one more textbook, Mechanisms and Machines Theory by G. Ambekar. We have a reference book, Theory of Machines by Ratan S.S. and one more reference book is Mechanisms and Machines, that is Kinematics, Dynamics and Synthesis by Michael Stenitz. So these are the textbooks and reference books which we can refer for this subject. So this is all about the introduction to the subject. In the next class, we will be beginning with the module number 1, where we will be studying about the definitions and the mechanisms. So I would suggest the students to have a geometry compass with you to have a neat sketches of these mechanisms, to practice these mechanism sketches, to understand the how the mechanisms will work, and in the examinations you have to draw these mechanisms and explain how the mechanisms will work. Okay, so it's very important to have a good sketches of the mechanisms in the examinations. So practice these mechanisms with your geometry using geometry compass. So we'll start this module number 1 in the next class. Thank you.